This video is about finding compositions of inverse functions. Okay, so what you know about inverse functions is still going to be true. You're going to, you work from the inside out. It's a composition. The inside, work from the inside, then do the outside. Okay, so what I do first is the arc cosine. So I don't really need to know what this angle is. I mean, I can solve for it, but why bother? Okay, what I really need to do is realize what was the cosine. If you remember SOHCAHTOA, remember back in the days we did SOHCAHTOA, it was so easy. Cosine was adjacent over hypotenuse, right? So take this, that it's cosine, draw yourself a right triangle, okay? And you know cosine is the adjacent over the hypotenuse. So the adjacent side is 2, the hypotenuse is a 3, okay? And I need to know what is, if this is theta, this is adjacent, this is hypotenuse, this is the opposite. So to know tangent, I would need the opposite over the adjacent. So I need to find what this opposite side is. Guys, we're right back at Pythagorean theorem days. Okay, so this is what I need to know. So I would take 3 squared minus 2 squared, and that's going to give me whatever, b squared. Okay, so 9 minus 4 gives me 5. That's b squared. So b is the square root of 5, right? So if I want the tangent of that, I take the opposite over the adjacent. So the tangent would be square root of 5 over 2. And that's all I have to do right there. Okay? Now, arc sine of negative 3/5. Okay, you got a negative fraction. You got to decide, is that negative with the 3 or the 5? Okay, the way it looks right here is a little tricky. So this is where you think about your arc cosine and arc sine. Now remember with sine, it has to be either in quadrant 1 or quadrant 4. Okay? One of those two. Well, in which quadrant has a negative y value, because sine is y. Where's negative y? So it's quadrant 4. So what that tells me about my triangle is that the y value is the negative. So this is negative 3. Remember, sine is opposite over hypotenuse, right? So opposite is 3, hypotenuse is 5. And way before we mentioned that the hypotenuse is never going to be negative, and that's still true. Okay? So we have our sine represented here, given to us by the arc sine. I want to know what the cosine is of this, though. Remember, cosine is the adjacent of the hypotenuse. So in order to know that, I need to find this side A right here. So I'm going to do Pythagorean theorem again. 25 minus negative 3 squared gives me 25 minus 9, which is 16. And that's A squared. So A would be plus or minus 4. Remember, when you take the square root of something, it's positive or negative of that. We already said that this triangle is down here, right, in quadrant 4. So let's think about your x values. That's this horizontal right here. Is it positive or negative? It is positive, okay? So that means my A will be positive 4. Okay? So it's positive 4. You always want to check to see what quadrant your triangle lies in to know if that x is really a negative value, okay? Now that I know that, I can know that the cosine of this is the adjacent over the hypotenuse, so it would be 4 over 5. All right? All right. So let's arc sine of tangent 4. Well, tangent, remember, has to come from either quadrant 1 or quadrant 4. And it's positive. So let's think about this. This is positive, positive, and this is, see, x is positive and y is negative. So for tangent to be positive, it means my triangle really is here in quadrant 1. Okay, so keep that in mind as you draw it. Tangent is opposite over adjacent, right? So if it's 4, that means the opposite side is 4. The adjacent side is 1. Here's my theta. I need to find the hypotenuse because I need to know what the sine is, and the sine is the opposite over the hypotenuse, right? So I'm going to use Pythagorean theorem one more time. So that's going to be 16 plus 1 is 17. Well, that's c squared, so c is the square root of 17. Positive or negative? Well, you know it's positive because it is a hypotenuse, okay? So it's going to be a positive square root of 17. Now, to find the sine, I take the opposite side over the hypotenuse, but I have to rationalize it. So I get 4 square roots of 17 over 17. Okay, and that would be my answer. Okay, let's look at one more example. Tangent of negative 6/7. Well, inverse arc tangent, remember, it has to come from either quadrant 1 or quadrant 4. And if for the tangent to be negative, remember the signs have to be different. So that means my triangle really is down here. So here's my triangle. Tangent is opposite over adjacent. Now, which one of these is the y? Well, 6 is the y. That really is done, it's down here. We just flipped it, okay? Now I've got to find the hypotenuse, because to find sine, I need the opposite over the hypotenuse, right? So I'm going to use Pythagorean theorem yet one more time. Now 6 is negative, but that's really not going to change a whole lot as I compute. So negative 6 squared plus 7 squared equals c squared. So negative 6 squared is 36 plus 49 equals c squared. That would be 85 is c squared. So c is the square root of 85. Now it's positive because it's a hypotenuse, right? I know c is positive square root of 85. Now to calculate sine, I take the opposite side, which was negative 6, over the square root of 85 and rationalize it. So I end up with negative 6 square roots of 85 over 85. Right? That would be the sign of this equation. So it's a composition. You work from the inside out, just like we've done before in the past with compositions. All right? Good luck, and hopefully you don't have too many questions, but we'll deal with them when you get to class.